All right, so in the last video we had introduced one-step problems, one-step stoichiometry problems, which is dealing with this section right here, being able to jump from A to B. So right here, I don't want to necessarily, I'll erase this and not confuse you with so many arrows, but that step right here, this is the jump from A to B, right? This is the jump from A to B, and you have to be in the unit of mole to do that. Well, as we know from last unit, or I'm sorry, last semester, we don't always start with the unit of mole. We also don't always necessarily want to end in the unit of mole, but we do have other conversions. And so what this is kind of like your mole map from last semester on steroids, so to speak. So let me try to block this out. Let's say that we didn't want any of this. Let me get rid of this. This is a light color, so I'm gonna never use it as much. But let's just say that we were back in last semester, all right, and we had our mole bridge. And so our mole bridge or our mole map consisted strictly of one substance. So you see, this is just substance A. So we really never had to worry too much about the change from one thing to another. We only did the difference in units, right? Moles to liters or mass to particles. So we had this little section right here that we worked on. Now with stoichiometry, what we do is we use those quantities, but we then also have our balanced equation that allows us to jump from moles of one substance to moles of another using the coefficients of that equation. So that's where we end up with this entire thing. Now, of course, it's done just the same way that we used our bridges before. The only difference is you could start, let's say you start at mass and you want the volume of the substance B. So you cross one bridge, two bridges, three bridges, right? Or for instance, you could start at volume and you'd want to get to particles of B. You start here, you cross one bridge. At this bridge, in order to get to B, you'd have to go through moles, and then you go down to particles. So you're doing exactly what we did before. The only difference is we're adding this portion right here, which is actually going from one chemical substance to another using those balanced equation coefficients that we did in last worksheet. So let's look at the chemical equation here for propane's combustion. We see we have 4. I'll have a 4 plus 6 is that, so that's a 5. And then I'll do a 1 as a placeholder. Again, I usually don't include the 1, but just so that you visualize those coefficients. If you want to add it, you can. So my example problem here, and in this one, I'm saying, well, what if we had 5.11 moles of water, and that's how much is produced? I want to know, well, how much of that propane had reacted in order to produce that amount? And we say, well, I identify that this is substance A because that's what I'm starting with a value for. This must be substance B, that's what I want. And then I identify what the unit is from start to finish. So I see that I'm starting at moles of A, so moles of A is where I'm going to begin. And then I want to get to grams of B, which is mass of B. So I'm trying to end there. And so I can look and say, how many steps is that going to take? How many bridges am I going to have to cross? Well, I have to cross this bridge. That's 1. And then I'm going to have to cross that bridge, which is 2, right? I go through the unit of the mole, and I jump from A to B using those coefficients from the balanced equation. And naturally, we're going to have to find the molar mass of the substance if we want mass at all involved. So we see grams is here. So right away, I know that I'm going to have to use the molar mass at some point, right? So here, I would say there's C, which is 12.01 times 3 H is 1.01 for a mass times 8. Add that together. I believe it's 4.11. Yeah. So 44.11 grams per mole. So just because I see the word gram, I know I'll have to calculate that at some point. So that's where I'm going to put it. So you identify what substance, right? We said moles, and this is A, of what we start with. Start with is always A. Asked to find is always B, right? And then you are going to, so you're dissecting the problem and identifying first. So you've been getting with your starting amount, including unit and substance, just like we've done before. How many bridges do we have to cross? Well, we said we have to cross the coefficient bridge to go from A to B. We have to cross the molar mass bridge to go from moles of B to mass of B. That's 2 additional fractions, right? 2 additional factor fractions. So then we do the last step, and then we just plug everything in. Noting that when we go from A to B, this is where we use the coefficients, right? This is where we use the balanced equation. So balanced equation. All right. And then, of course, all other points outside of this where the mole unit is involved, everything is equal to 1 mole. And that's very similar to last semester. You work through this, and then you end up getting your answer. Of course, you need a number, a unit, and a substance. And that would receive full credit there for all of your answers, and even as you go through, so that you know what's canceling out as you go through and what you're ending with in the end. So let's do another example, and then I'll kind of leave you to it. I am starting with this many moles of this substance. Because this is my starting point, I know that propane now is substance A, so it's not always just the first substance you are seeing in the problem. It's whatever you have a starting value for. So moles of A, and I'm looking for grams of this other substance, O2, which is grams of B. And just like any other problem, moles A is C3H8 over 1. Now I look, and I'm going to add, I know I'm going to need at least 1 bridge to cross, moles of A to grams of B. Very similar to above, moles of A, we're going to have to cross 1 bridge to get to moles of B, and we're going to have to cross 1 more bridge to get to mass of B. So that's a 2-bridge problem, which means we're going to have 2 additional conversion factors here. Moles of A go on the bottom, so C3H8. Moles of B go on top, so O2. And the ratio here, again, is going to be from our recipe, right? Going from one thing to another, we go to the recipe, which is our balanced equation. Our balanced equation is right up here. We know that there's 1 mole of C3H8 for every 5 moles of O2, and so I put those accordingly. 1 mole of propane is equal to 5 moles of O2. Now in this next step, moles of O2 go on the bottom to cancel out, and grams of O2 is what I will end with. Now, of course, because we're talking about grams and mass, I need to figure out what the molar mass is of this. Well, 16 times 2 gives me 32 grams per mole. So that's how I know for every 1 mole of O2, there are 32 grams of O2. And then we solve. So we get, I'll do this one on the calculator here. We have 0.76 times 5 on top times 32. That gives us 121.6 all over 1, because all the numbers on the bottom are 1. That's fun. And then we end up with 121.6 grams of O2. So that is a complete answer there. Let's try one where we'd have to go through a couple more steps. Let's do number 2 here. let's do number 2. So I want to go from moles. Well, I'm sorry. I have liters, and this is what the substance is that I have it for. So that's A. I want moles of this substance, which is substance B. So we're starting with, if we go all the way up to our map, we're starting with the unit of liters, which is volume. There we go. So we're starting with volume. And we're trying to get to moles of B. All right, moles of B. All right. We're going to do a little bit of scrolling here. So liters A, moles B. That's why it's very important to be able to label or annotate your problems. So then I go, okay, well, in order to get from liters of A to moles of B, what's the route that I have to take? So that's liters of O2. How many bridges am I going to cross? Well, I'm going to cross this bridge here to get to moles. Then I'm going to cross this bridge here to end at moles of B, which is going to cause me to have 2 conversions. So 2 extra conversion factors there for the problem. And now I go through and I say, well, liters of O2 is going to turn into moles of O2. And then moles of O2 is going to turn into moles of Al2O3. All right, so we're canceling out our units. Based on my conversions from above, we're always assuming that we're at STP for these, which means we can use the 22.4 liters is equal to 1 mole conversion. And then, of course, because this is the step where we're going from A to B, we need to use the balance equation. So we need to balance this equation quickly. We're going to need 2, 3, and 4. Right, so now we have a balanced equation to work through, and now we just kind of plug in the coefficients. For every 3 moles of O2, I have 2 moles of aluminum oxide there. And we solve, right? All of our units cancel out along the way. And so 125 times 2 is going to give us our 250. 1 times 22.4 times 3. Again, I'm ignoring ones because we don't need to worry about them. That's when we have our 67.2. 250 divided by 67.2. That's going to give us 3.72 moles of aluminum oxide. Right? So it doesn't necessarily matter what unit we start with nor what unit we end with, so long as we can kind of use the map to help guide us through. And it tells you what those coefficient or what those conversion factors are as you work through. So hopefully this is a nice little stepping stone. And you know what? Let me do one more. So let's do number 4 here. And I want to do number 4 here because this one is going to be a little bit different in terms of going from something that's a little bit more and going to something that's a little bit more than just the mole value, or the mole unit itself. So over here, I know that I see I have 2 and 3, so I'm going to flip-flop those for the coefficients. So I'm going to have 3 here, I'm going to have 2 here, which is going to cause me to have 6 there. I believe. No, I'm sorry. It'd be a 3 here. So here's our balance equation. Again, I'll put the 1 there as a placeholder for now. But in this case, let's identify what we're starting with, what unit, what substance, what we're trying to get to. We have grams of calcium phosphate here. And we're trying to get to grams of calcium sulfide. And then we have our 357.2 grams of calcium phosphate. And it might seem monotonous to add all of that information in the problem itself, but it's going to help you keep track of everything. And we are going to be grading the units with the substance associated with it. So make sure you start to get used to including all that information. So I'm looking at grams of A. I'm trying to get to grams of B. So I'm going to go all the way up, and I'm going to identify how many bridges would I cross to do that. Well, grams is mass, so this is where I'm starting. And then I need to get to mass of B, so how am I going to do that? Well, I'm going to go through the first bridge with the molar mass. I then need to go through the second bridge to get from A to B, and then I'm going to do one more step, which is going to finally get me to the mass of B. Notice, you're talking about the mass of two different substances, which means you need to get the molar mass of two different substances. So down here, we need to figure out what the molar mass of calcium phosphate is going to be. And we also need to know what the molar mass of calcium sulfide is going to be. And so we can go through that. We have calcium, which is 40.08 grams times 3, plus phosphorus, which is 30.97 times 2, because there's 2 of those phosphate groups, plus 16 times 8 because of the 2 phosphate groups. All right, and we get 310.18 grams per mole. We're going to do the same thing for calcium sulfide. In this case, it's just 40.08 plus 32.07, which is 72.15 grams per mole. So because I know I'm going to be dealing with mass on both ends, I want the molar mass of both of the substances. So now we go to work, and we know that we're going to have to cross 3 bridges here. 1, 2, 3. And then we can include units. So we have grams of Ca3PO4 2 to moles of Ca3PO4 2, 1, and 3, 10.18. Grams of that cancel out. Moles of Ca3PO4 2 to moles of CaS. This is our step where we go A to B. And then we go 1 mole based on my balanced equation to 3 moles of calcium sulfide based on my balanced equation. And the last step would be moles of calcium sulfide, 2 grams of calcium sulfide, and this is where I would use the other molar mass. So 1 mole is equal to 72.15 moles or grams of that. And then you're going to simplify. Because I don't have enough room to add an additional step, I'm just going to do this all at once. If you like to do the simplification, you still can. So I'm going to do 357 7.2 times 3 times 72.15. So I've just accounted for everything on the top there. That's not 1. And then I'm also going to just divide 310.18 because it's on the bottom, which is effectively what we do anyway. And this gives us 249.26 grams of calcium sulfide. So why is this useful? Well, it allows us in lab to be able to say, if I have this much to start, based on that starting amount, there's the bell. Based on that starting amount, how much of one of my products, or however many of my products I want to talk about, can I expect to make? Now, will you actually make this? Not necessarily, and we'll talk about that at a later time during this unit. But hopefully that's enough examples for you to kind of hit the ground running with this. So if you have any questions, again, as always, just let us know. All right, and we will see you later.